Okay, today we are going to cover functional analysis, which is the second of 3 steps in the reverse engineering process. We did the visual analysis first, where we looked at the elements and principles of design that are evident in the object that you've selected. And now we're going to do a functional analysis as the next step. So after a product has been selected, a non-destructive, which means that when I do the functional analysis, I don't take it apart. I'm going to be making some assumptions or a hypothesis about what's happening internally, so we're not going to take it apart quite yet as part of a functional analysis. First, the product's purpose is identified. Next, observations are made to determine how the product functions. These observations are recorded in detail, so we're going to make a guess about how things work internally. And then lastly, the system's inputs and outputs are determined and or listed out. So if we're using an electric toothbrush as our example for this PowerPoint, we're going to determine the purpose for this, and it is to clean teeth and gums to prevent tooth and gum decay. Water and cleansing paste or toothpaste are used in conjunction with the toothbrush. So a lot of the objects selected, in order to function or to complete its purpose, there needs to be other inputs or other things that go along with it. Next, we want to create an annotated sketch with all visible components labeled. A hypothesis is devised to describe in detail the sequential operation or function of the device using the sketch as a reference. So I'm identifying all the different parts of my object with annotations or labels to point those out. And then I'm going to use what they call a black box system model to identify what goes into and out of the product in order to make it work as a system. And the purpose or the reason that it's called a black box is because the internal components of the process is unknown at this point, since we're not taking it apart. And so we're speculating about what is happening internally, and that's what the hypothesis came up with. So looking at then the inputs and outputs for a electric toothbrush, we have hand motion, because by itself the toothbrush isn't going to brush your teeth. You have to have hand motion. There's toothpaste, water, energy from the batteries and stuff like that. And then our outputs, what we get out of it are sound, right? If I turn this on, it typically makes a sound. We can have heat that's created by the friction of brushing our teeth, waste, and then cleaning teeth and gums. And so you're going to do something similar for your object. Some of your outputs might be a stretch, but let's put some thought into what those might be. Okay. Let's look at today's activity. So this is 6.3 functional analysis. Make sure that you're using the alternate activity, so using the right Word document for this, since we're not doing the audible blocks. And in this activity, you're going to work through this Word document. Name of your product, company name if you can find it. Sometimes they're generic and they're not going to have a company name. Identify what the purpose or primary function for your object is. If it's a toy, say it's used for entertainment or it's used for educational purposes. Sketch an isometric pictorial. You can actually draw this out, or if you want to find it or have an image or a photo of your object, you can use that as well. And on that image, you're going to add your annotations. Make a guess about how the product operates. So you may have already taken it apart, but let's assume that you don't know the internal functions. Speculate on what is causing your product to move or what's causing your product to complete its purpose. And then finally, we have the inputs and the outputs. So like for the toothbrush, the function was to clean teeth. That's what was placed here. And then it listed out all the inputs that go along with it and the outputs that we get as well. A couple more questions to answer along with the conclusion questions at the end. All of this can be done directly on your Word document. Let's look at one more example that goes along with the toothbrush. I have basically a stapler that I'm using the Word document that you're going to be working on. It's the product, the name of the company, what its purpose is. Here's my annotated sketch of the stapler, identifying all the different components. Quite a bit of speculation on how the internal components work. And again, the function basically for the stapler is to fasten paper together. We have staples, loose paper, and applied force as some of our inputs. Noise, heat, and bent staple as our outputs. So this is going to go directly on the Word document. If you want to sketch in your notebook, you can. Just make sure you submit that separately. Let me give you 2 days to get the functional analysis for your object completed, and then we will move on to the last step of reverse engineering, which will be the structural analysis.